Hey everybody, so today we're working on a linked list Leet code problem called Flatten a multi-level doubly linked list. And so since I was having a hard time understanding this, I kind of created a, di a visual diagram of it basically to work through it so I can understand it and hopefully you guys can as well. So let's go through this problem. You are given a doubly linked list, which in addition to the next and previous pointers, it could have a child pointer, like this one, which may or may not point to a separate doubly linked list. These child lists may have one or more children of their own, and so on, to produce a multi-level data structure, as shown in the example below. Flatten the list so that all the nodes appear in a single level doubly linked list. You are given the head of the first level of the list. Alright, so given an input such as where head is, like this 1, 2, 3, 4, 5, 6, no, 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 7, 8, 9, 10, no, no, 11, 12. So that's kind of how the input is set up. I'm guessing these nodes are counting how many nodes after there was a node with a child, and the output is going to be like this: 1, 2, 3, 7, 8, 11, 12, 9, 10, 4, 5, 6. So it's going to look like this diagram below: 1, 2, 3, 7, 8, 11, 12, 9, 10, 4, 5, 6. So whenever there is a child, the next node that you're gonna level it out is gonna be the child, and then following the next one if there is no child, right? And then for the example 2, let's say if it was if the input was a 1, 2, no, and 1 had a child, it would be 1, 3, and then 2. And in example 3, where there is an empty head, then we're just going to return head, which is empty. Okay, so let's take a look at what they're talking about here. How multi-level linked list is represented in test case. We use multi-level linked list from example 1. Okay. Well, I guess we're just gonna ignore the rest of this. So, all right. So I already wrote down the solution here, but let's just go ahead and jump into the diagram that I worked out, basically. Okay. So hopefully this is pretty clear. All right. So this is originally what we're starting off with, right? And let's go to the next slide. All right, so starting off with the initialization of the function, we're just given the head node, and so we know that the base case is basically if head is none, then we're just going to return head itself, which was in the example 3 earlier given. So that's the base case. So since for this example head is not none, we're gonna skip this if case and go straight to p equals head, which I show here. So let's make a pointer p and point it to head. All right, so what we know that we should be doing is that by the end of flattening out our doubly linked list, our case should be basically at the end when it's completely flat. When it's completely flat, that p should be none, right? So we're gonna run through p all the way to the end, and p is gonna be empty at the end of 6, right? So let's start off with this case, this while case where while p is not equal to none. And so given the case, we know that the first case is going to be that if there is no child, then we're going to proceed on to the next pointer, right? And so let's go ahead and start with that. So right now, while p is not equal to none, which is not case 1, does 1, if p right now, which is 1, if the child node is none, then we're going to continue on to the next one. And so since p doesn't have a child, we're going to go step into this if case, and we're going to just say p is going to be equal to p.next, which is going to point to 2, and then we're going to continue. Okay, so we're going to keep continuing on again. If p doesn't have a child, then we're going to proceed on to the next one, which is true. So, all right, so now we've reached the first node where there is a child. So this is case number 2. Case 2, if you have a child, find the tail of the child and link it to p.next. So then that means basically we're going to find the tail of the child and link it to p.next, which is 4. So basically we want to link 10 to 4 at the end. So in order to do this, let's go ahead and first make a temporary pointer pointing to p's child, which is 7. Alright, let's do that right here. So this purple is the temp. Okay. Now that we have a pointer at the child, a 7, let's go ahead and find the tail of the child, which we know to traverse is just a basic while temp.next is basically not none, then we're going to just traverse. So temp is going to be equal to temp.next. And we're going to keep going till we reach this. Now temp.next is null, so we're going to exit out of this while loop, and we need to find the tail of the child, which we have, and we need to link it to p.next. So that's going to be the next slide. So basically, before I go on to the next slide, you can basically see, before you guys get confused, since we want to point the tail of this child and link it to p.next, then basically we can move everything here from 4 to 5, 6 is going to be after this 10, right? So that's the reason why I moved everything to slide it over, so you can kind of see it, right? So we're going to say, in order to link it to p.next, we're just going to say that temp.next is going to be equal to p's next, okay? And so p's next pointer is still pointing to 4 technically right now. But as you'll see later, this next pointer is actually going to need to point to 7 later, since we're flattening out the linked list. But that's later. All right. So now that we have pointed temps next to p.next, if it is not null, then we need to point this previous node to temp, right? So p's next, since p is still pointing to 4, we're going to say if p.next is not equal to none, then we need to point p.next.previous to temp so that we can connect the doubly linked list. So now this right here is a doubly linked list. 4 is going to be 10 and 4, and 4's previous is 10. Now that we have done that, we need to close off this and actually flatten everything from here and push it in between here, the 7 all the way to 10, and basically pointing to here, and then deal with the next child pointer. So what we need to do here is to connect p with p.child and remove the p.child. So what we're going to do here, since p is still pointing here, we're going to do p.next is going to be equal to p.child, and then we're going to say p.child.previous is equal to p. Now that will be a doubly linked list where the next pointer is pointing to 7 and the 7's previous pointer is pointing to the previous number, which is p. And then we can set the p.child to none. And from there, you can basically see I moved all of these 4 in between here. Okay? So don't be confused with that. All right, so now that we've done that, and this is a lot more flat, that's basically this while loop and all that it does, okay? So now that we've got to that point, we're gonna start back up at the top here. Let me see if I could zoom in a little bit more. So you can see a little bit better. Gonna move this. All right, so okay, so now let's go ahead and continue on with this while p is not equal to none, which is not. We're gonna start back up to this case. So if p doesn't have a child, which we already removed the child as we've seen earlier, we're just gonna continue traversing until we reach to the next child pointer, which is at 8. So if p.child is equal to none, which is not, we're gonna traverse p equals p.next. Okay, so we're gonna traverse to 7 and then to 8. Now we're reached the case 2. If since we know now p.child does exist, we're gonna just exit out the if case. We're gonna continue on here. Let's go ahead and initialize another new temp to p.child. And like before, we're just gonna find the tail of this, which is gonna be 12, and we're gonna traverse. Okay. So now that we have found the tail of the child, then what we need to do is point this 12 to p's next pointer, which is 9. And like before, since we need to check if p.next exists, then we're gonna connect the previous to the temp. Okay, like that. All right, now that we've done that, just ignore this arrow. Now we need to connect p with p.child and remove the p.child. So what we're gonna do is p.next is equal to p.child, and then you'll see that we're gonna need to do p.next's child previous and point it back to p, and then close off p's child and take that out. So now it has no child. And as you can see now, we have now we can just traverse a list and just keep going. Since you can see p no longer has a child. Once when we reach to the end where p.child still doesn't have a child, and now that p is officially at none, we're going to exit this while loop. And at this point, we could return the head, and we have our flattened out doubly linked list. And so hopefully that makes it a little bit more clear. And yeah, this is just my way of kind of trying to understand how to do this problem, and hopefully it's helped you. And so yeah, good luck with studying Leet code, everybody.